Hopefully your trigonometric relationships are coming back with the sine of a 30, cos of a 45, etc. Because we are going to go back and forth between polar and coordinate, rectangular today, and also next week. So there was a lot of information yesterday. Today, not so much, maybe a little bit of graphing. The worksheet is a lot of just review. And then I'm going to put out a formal assessment on Thursday again for Friday. And then we'll pick up on 10-7 again next week. Once again, good luck to everybody that's taken AP tests. That's why I'm kind of just slowing down here a little bit. All right, so first of all, we do need to have our relationships in general that relate polar, which always has the r and the theta, to rectangular that contains the x and the y. And so first thing, I've got a rectangular. Now, of course, that's the equation of a line. And I even have a graph here that I wanted you to real quick. We're going to begin at -1. Let's do our slope up to right 1. So this equation in rectangular form is a line. It would also be a line in polar. And you'll see kind of both things when we change from polar to rectangular. So here it is rectangular. We know it looks like a line. What does a polar equation look like that would go with this shape over here, the line? And so I'm going to substitute and get rid of y, which is r sine theta. And I'm going to get rid of x, which is r cos theta. And then it was -1. Now, when you put something in polar form, this is one of those, again, what's the final form look like? Sometimes there's more than one. We will definitely try to solve for r. That's what we're going to say we want polar form to look like. So in this case, I've got my r sine theta. Just get rid of these parentheses, it's multiplication, 2r cos theta. Okay, I don't distribute the 2, it's just one multiply number there. I'm going to move this term over to the left-hand side. So therefore, it would be -2r cos theta equals -1. I'm going to factor out the r. That would leave me the sine of theta minus 2 coses of theta. And then last but not least, we will divide by that entire quantity. So it is -1 sine theta minus 2 cos theta. That's the line in polar equation. That's the line in rectangular. All right, moving on. We're going to do another one. Here's rectangular. And hopefully you recognize that that's a parabola. One of the variables is squared, so it's a parabola. And it's my parent function parabola, so 0, 0, 1, 1, -1, 1. So there's my parabola, -1. All right, so there it is in rectangular. What's it look like in polar? So y is r sine theta, x is r cos theta, quantity squared. That's r sine theta, and we're going to square the r and square the cos. Now we said we want to make this say r equal. So in this case, we can divide the left side by r and the right side by r. We know r is not equal to 0. We don't have to worry, because if r doesn't equal 0, if r equals 0, we have nothing. We will be at the pole. So if I cancel that out, I will have sine of theta. Again, I can divide by r because I know it's not 0. Simplifying that r squared and the r, cos squared theta. And then we want it to say r equal. So we have sine theta, cos squared theta. Now, here's where you have to be aware there could be more than one form on this thing. Right now it's written as a fraction. We can simplify that farther. In other words, if I split this fraction up and say, why don't I do the sine of theta over one of the coses, I'm pulling the fraction apart, times 1 over the cos of theta. So let me make sure you see, normally we put them together and we'd have cos squared, sine on top. I pulled it apart. And when I did that, now I can simplify that to say tangent, and I can simplify that to say secant. It is the reciprocal. So this would be the best answer. And that's what you'll be striving for on WebAssign. They will not have that answer. You are looking for where the fraction could be simplified. All right, now let's go the other direction. So what if, so now I've got my polar paper, and that's why I'm having you do worksheets so I can give you guys the polar paper. We've got a polar equation, and we're going to change it to rectangular form. All right, so I've got the r is 2. So all points on my graph, all points are 2 units, 2 steps, whatever it is, from the pole. All right, r is 2. So if I go to the pole and I walk out 2, 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 you can of course see I'm going to end up with a circle on the ring that's 2. So I'm going to get a circle. Because everywhere if I walk out 2, the radius is the same distance. So now let's change form. So if this is a circle, do you kind of have that general form of the circle again? R, well, I had them back over here. R squared is x squared plus y squared. So r is going to be the square root of x squared plus y squared. And why don't we square both sides? I'm sorry, that shouldn't be r squared. I was thinking the equation of a circle. That was a 2. I replaced r with its equivalent, and 2 should have still been there. So square both sides, and I get x squared plus y squared does equal r squared, but in our case it is 4. And so there's the equation of a circle. The center is 0, 0, and the radius is 2, the square root of 4. Okay. All right, what if now the angle is set? The angle is pi over 4. So it's all points that make an angle of pi over 4. All right, so here I am at the pole, and this is pi over 4 right here in between. So I'm going to, if I walk out 1, have an angle of pi over 4, walk out 2, walk out 3, walk out 4, walk out -1, negative. And so what we get, this isn't very neat, we get a straight line. All right, because I am making a pi over 4, so I'm walking towards the terminal, I'm walking away, and I end up getting a line. All right, so it's a line in polar. What's the equation look like in rectangular? All right, what we'd like to do is convert. Let me again get my little guys back here. I'm going to use my tangent relationship because that'll bring in x and y. So I'm going to take the tangent of the left-hand side, theta, is equal to the tangent of pi over 4. So the tangent of theta would equal the tangent of pi over 4 is 1. And tangent of theta is y over x. And if I cross multiply, I get y is equal to x. A line right through the origin. You can kind of visualize there's the coordinate plane right through the origin in between the quadrants. All right, last one. Now, when I look at this, I don't quite know what that is. You know, this one was a little more, the angle's going to stay the same. This one, the R was going to stay the same. But this guy's not as obvious. So what we want to do, since this is cosecant, I would like to bring in his reciprocal, sine. And I'll show you why. These are techniques that you get to see. I'm going to multiply the left-hand side by the sine of theta times r. And I'm going to multiply the right-hand side by the sine of theta. And then we got cosecant of theta. Now this, I'm just going to put the r in front. That's r sine theta. Here's why I multiply by sine. Because these guys are reciprocals of each other. This is the sine of theta over 1, and this is 1 over the sine of theta. Reciprocals. So right away, I'm getting rid of theta. And now I have r sine theta. I'm actually getting rid of sine theta. Well, now I need to still get rid of r and theta here. And of course, I have the direct conversion that y is r sine theta. Y is equal to 1. So what is that? That is a horizontal line right through y is 1. So here's the ring 1. 1 is right there. Horizontal line right through there. Okay. So on the worksheet today, I gave you the 3 shapes that we've done here. Same idea. And then next week, we'll get into a little more complicated equations that will change form with. All right, good luck everybody on AP stuff as I mentioned earlier, and have a good day.